Here are some instructions to help you with Lab 9, TIDES. I have a picture here from a YouTube video that I asked you to watch, along with watching these instructions, which shows you some tidal bore surfers. And this is when tides go up into rivers from oceans and create a wave that surfers can ride for a very long time. When I put this lab together, I realized that most people don't really care too much about the tides. There are a few people who live and work near places where this is really important, but in general, most of us really don't think about it. So I tried to make the exercises in here relevant, as if you needed to know about the tides to solve certain problems. But we're going to start out with some vocabulary. The terms on the left are important concepts related to tides, and you should have watched the first Unit 8 video, 8.1, which introduces you to these concepts. You can also, of course, look them up in your book or online. One thing I want to make clear is that this is not a one-to-one relationship between a term and a definition. Sometimes I have students who just draw straight lines across. This is scrambled. This is supposed to be something that you're supposed to figure out which word goes with which definition. So I'll give you one for example. An ebb current is when water flows out of a bay or river as low tide approaches. So just keep in mind that that's what this page is going to look like, a bunch of kind of crisscrossed lines. Now it says to ask your instructor to make sure you've matched these correctly. You're welcome to send me an email or contact me during office hours, or you can just go on ahead. I think most of you can find the definitions and match these up. All right, so the first question on the left asks you to look at this tide chart and answer some questions about it. So let me make sure you're clear on what you're looking at. So first of all, across the bottom we have time, and then on the y-axis we have height, and this is in feet. So the blue line is showing the tide level over this 2-day time period at different times of day. So at midnight, this is military time, the tide is about 5.5, 5 3/4 feet above the 0 mark. And then as time goes on, this is what the tide does. It goes down, up, down, up, down, up, down, up. So the first question asks you how many peaks are there each day. So I want to make sure you're clear on where the days are divided here. As I said, this is military time. So 0000 is midnight, 800 is 8 a.m., 1600 is 4 p.m., and then we're back to midnight. We used this military time when we did the moon project. Each of these little hash marks represents 2 hours. So this is midnight, 2 a.m., 4 a.m., 6 a.m., 8 a.m. As such, this set of 3 columns represents a day. So this is midnight to midnight on July 24th and midnight to midnight on July 25th. So you need to make sure you realize when you look at each of these graphs, which are all a bit different from each other, what time frame you're looking at. So the question asks how many high tides are there in each day. Now you might look at this July 24th day right here and say, well, there's one right there. But a high tide is any time that there's a peak. So this right here is a second high tide in this 24-hour time period. The next part asks if there's more than one. Are they the same height above the MLLW, which you defined on the first page? And in this case, the MLLW is going to be the 0 foot mark here. Basically, it's a line that's considered the 0 mark, and then the tidal height is measured above the 0 line. So go ahead and answer these different questions about this diagram. One part that I know students get confused about is this last part that asks about tidal range. So a range is the difference between a maximum and a minimum. It is not the difference between the maximum and the 0 line. Okay, so the range is not between these two places. The range in this case would be between 1 foot and maybe 6 1/4 feet. if you think that's the maximum. There might be another part on this diagram where the range is even bigger. Okay, moving on to chart 2. Now this shows also 2 days worth of data, but there are other things listed on this graph. So in blue, we have the predicted tide. In red plus signs, we have the observed tide. So you can basically see that the observed tide was about a half a foot higher in general than what was predicted. And then in green, we have the difference between observed and predicted. So this is about, like I said, about a half a foot higher during those 2 days than predicted. So again, you're going to answer these questions. And the one that I know gives people a little bit of trouble is this last one that says, did this area experience an ebb current or a flood current around 10 a.m. on March 21st? So March 21st is this first day. And now you need to know where 10 a.m. is. So remember we said this is midnight, this is 8 a.m., and every little tick mark, although you should always check because this could be different from this one, is 2 hours, right? So 8, 10, 12, 14, 16. So that's correct. So 10 a.m. is right here on this, at this position. Okay, so right about here in terms of the actual data. So is this area at this time experiencing a flood current or an ebb current? And I'll let you figure that out. Question 3 shows yet another kind of tidal chart. This one shows an entire week of data, not just 2 days. And in this case, the dark shading indicates nighttime, and the yellow shading indicates daytime. And so you can even see down here, there's sunrise, sunset, sunrise, sunset, sunrise, sunset. So a 24-hour time period is from the middle of one of these gray bars to the middle of the next. There's another day. There's another day. And to help you out, I suggest you take a piece of paper and place it at midnight on one of those days and midnight the next day. This is one 24-hour time period. And I think it's easier now to see how many crests and troughs there are in this wave. So you're going to answer the questions. Again, there's an MLLW, which is the 0 point. This would be the 0 meter or 0 foot mark. You might get stuck on the last question. It asks you for the name of the moon phase at the beginning and the end of this particular week. Well, how would you know that? Well, it's because actually they have the full moon listed as occurring right here at this point in time. So knowing what you know about the moon and the pattern of the moon, what happens before it, a couple days before the full moon, and what phase is it a couple days after the full moon. We then have a different kind of tidal chart, and this one is showing a whole month, and we've got high, low, high, low, high, low, high, low, indicated by the blue bar. Now, this is something that I've actually done quite a bit, is I take my students down to Cabrillo Beach and we look at the tide pools. And the key is we want to go when the tide is as low as possible because then we'll see as much as possible. You're asked to do 3 things. First, consider this entire month and tell me when the best date and time would be to visit the tidal pools. And this is irregardless of whether it's the middle of the night or it's a Tuesday. Just pick the best day overall and time. Then the next part says, well, they have to be able to visit the pool between noon and 3. So now do that exercise again and find out where the best viewing will be between noon and 3. The times are shown as midnight, 6 a.m., noon, 6 p.m., midnight. And then finally, I tell you, well, actually, we can only meet on a Friday. So now you have to find the best Friday that fits these requirements. Number 5 has to do with the tidal bore surfing. Again, we have a whole month of tidal information. And the key that you need to know when you read all this is that the greatest tidal range is when we have the maximum tidal bore waves. The window of opportunity is 2 to 3 days before and after the phases of the moon that create these particular greatest ranges. and that the bores usually arrive about an hour or so after the predicted low tide. So you are again asked to select the best day that would be for surfing, and keep in mind that people don't surf at night in the dark. Select another day. So I want you to basically have two different options from two different times in the month. And then the last question basically asks you when would be the worst time to do tidal bore surfing. Question 6 here shows another one of these month-long maps, and it's asking you to predict when a boat can safely pass a reef that's at the 8-foot level above the MLLW, and it has to be around midnight. Just you read this little story here. Now it's kind of hard to read the elevation of the tide here, but there I've highlighted the 12-foot mark and the 6-foot mark. So if you look at this carefully, you'll see those indications of the height of the tide. And then finally, you're going to do a little investigation at this website. I just checked the website. It works. It's all good. Of course, it's been updated, so you don't have to quite follow these instructions. It says click on countries J to R, click on Mexico. Instead, you just have to type in the word Mexico. Then you actually can click on Puertecitos, and it asks you to describe what's going on that tide chart. And so I'll let you read these questions. Finally, the last one says, using this website, go to 3 other areas in the world and describe the kind of tidal pattern, diurnal, semi-diurnal, or mixed. So that's really wide open. You just have to find 3. You could try to find one in each category, and that's up to you. But I want you to just check out the website. And that's it.